offering advice and feedback on what we're doing. And we don't operate in a bubble, and we couldn't do a fraction of what we do without the support. So thanks to these people. And I'm going to move on before somebody realizes that I inadvertently left their name off that slide, because it's inevitable when there's so many people that have been instrumental to us. A bit of an overview about our program. Most of our funding comes through the Canadian Agricultural Partnership. We're involved in 4 activities in that. This activity 4 is a collaboration with a breeder in Kentville, Nova Scotia, and really our part of that is sort of embedded in activity 2. And so broadly, activity 2 is all the work that we're doing, sort of developing tools for breeding and doing crosses and making selections. And then activity 3 is sort of the downstream testing of selections. After we've made those selections, we put them into yield trials, put them into grower trials, and that sort of thing. Our program is now more than half blueberry. We're still got a big chunk of raspberry, strawberries hanging on there. We don't want to ignore those, but they are a far smaller chunk of what we're doing. And here's sort of a rundown of kind of where we are with the priorities of what we're looking at in those 3 crops. A bit of an overview. This sort of ties into what Pat was just showing. He sort of gave the timeline with the WSU selections up there, and the materials released from that program. And you saw that it's about an average of 15.5 years for the WSU raspberries. This is the timeline that we're sort of projecting for our raspberries and blueberries. If everything goes smoothly, it's going to take about 15 years to get something out the door. Obviously, a little bit less for strawberries. I would expect that to be more around 10 years. Our blueberry program in particular is newer. The first crosses in our blueberry program were only made in 2008. So we're still sort of in this range on the blueberry program. Our strawberry and raspberry programs are much more mature. I'm going to give a little bit of a different presentation from what I often do. I'm going to sort of run by some numbers and give a little bit of a summary overview of some selections, but then also talk about some of our other projects. I think that if I were to just flip up slides with pictures and numbers, I'd probably get 3 or 4 selections into the program and everybody's eyes would start to glaze over and nobody would be able to keep the numbers straight except for me and Pat and Chad. Sort of a summary of what we've done this last year on blueberries. We've got about 8,000 seedlings from crosses that were made in 2018. Those are finishing up in gallon pots right now. They'll go out to the field in the spring. We made 61 new crosses. Those are germinating right now. We'll be done moving those into plugs here in about a month. We evaluated a lot of seedlings in the field, made somewhere between 70 and 80 new selections. I don't have the exact number handy when I made this slide. Yield trials at Clearbrook. Sort of highlight our approach on the blueberries is we've heard from growers, they really want to get stuff in their hands and try them. And we say, well, but it hasn't been tested. And they say, oh, let us help test. So our approach has been to sort of try to identify a few things each year that we think might have potential, sort of the top of our list, and try to get a few plants out there for growers to look at. And so we're basically limited by how quickly we're able to propagate plants. And you'll see some pictures here in a minute on some of those selections. 1440 158 is one that we've gotten into some trials. Initial reviews on that is people are really excited about it. So we're going to try to get more plants out there. 1440 14 is one that we had flagged for grower trial a few years ago, but we had some difficulties propagating it by TC in our lab. So we sort of shoved it down the list and said, well, let's put it in our yield trials. And if it looks good, then we'll worry about getting it into grower trial. We got a lot of feedback on that at our field day this last summer. People were excited and interested in that one. So it's moved back onto the list to try to propagate for grower trials. Here's some newer selections, evaluating the seedling field for over a couple of seasons. Again, good feedback at our field day. They looked good in the seedling field, and we say, okay, let's get those out there. So these are entering the propagation stream. That means it's probably going to be a few years before there's plants out there for us to get into the field. These are ones that we started propagating a few years ago. We'll get some 1268 and some 14876 out the door this year, this next year for growers. 1268 is an upright, very, very firm one. And I've got a picture of that one coming up. 14876 is a very large, it comes in, I would say it's slightly later than Duke, not as, it's somewhere between Duke and Draper season, but it's a nice, large, vigorous plant, large berry, vigorous plant. This is 1268, very, very firm. Concerns on this one is it does tend to hang on to the corollas a little bit. And you can see that here in this picture as well. That is a potential risk for botrytis fruit rot, but there's also a possibility that that can interfere with soft sorting equipment when it goes down a packing line. So we're a little hesitant, but people have seen it in our yield trial and said, well, this would be interesting to look at. So we're going to try to get some plants out the door. I mentioned 144158. This is a narrow vase-shaped bush. Decent vigor. It's blue crop-ish season, maybe slightly earlier. Medium color, firmness similar to Draper. It sets a lot of flower buds. So pruning will probably be important on this, but this is something that we're going for in our blueberry program is we're trying to identify material that sets a lot of flower buds on whips, with the idea that if you can carry a lot of your crop on 1- and 2-year-old wood, then wood that's 3 years old, you can just make some big cuts, get it out, and it'll hopefully simplify pruning if you can combine that with reducing the number of little spur growth coming off of some of those 2-year-old shoots. So the idea here is getting a consistent crop, but also hopefully it'll simplify pruning. And then some pictures of some other ones that were identified to propagate for trials a few years ago. These are in the propagation stream right now. So hopefully in the next couple of years, they will be out the door to start getting some initial looks at. Our objectives on the blueberry program, we did a survey of growers. I think it was, I came to the program in 2011. I can't remember whether it was that first winter or the following winter. I think it was probably the winter of 2011, 2012. We started a survey of growers trying to identify what their priorities were for the blueberry program. Overwhelmingly, traits associated with machine harvestability and particularly machine harvestability for fresh, firmer fruit was stuff that they wanted to see. Surprisingly, we thought people were going to say, you know, we'd kind of like to see middle, late, and late season, but it was almost an even split between early and late. And so we're sort of taking the approach, we'll try to identify things that span the season with concentrated ripening periods. There was also a survey that went out a couple of years ago, a group in the US working on an SCRI grant that we were involved with. And so it's sort of updated and identified and refined some of the breeding priorities that we're working on. This slide is old data, but it's highlighting just sort of, I'm just trying to get that red dot off the screen until I want to see it again. This just highlighting, we're trying to put a lot of emphasis on breeding for firmness. And this was sort of our emphasis out the gate. We're looking at firmness, and we have a selection here, 12-6-35, much, much firmer than even Draper. And we've used that heavily as a parent. It's been a great parent for firmness in our program. Another slide here, you can see these BC selections at the end again, considerably firmer than what the industry's already got. And that's the direction we're trying to go with our program. And then we sort of had a realization, I think probably about 3 years ago now, we were playing around with some stuff and we realized, you know, we've got this stuff that's really, really firm. We put it on the Firm Tech. It crunches when you bite in. It's really nice, pleasant sensation. But if people are wanting to machine harvest for fresh, firmness isn't necessarily what we need for that. We need fruit that won't bruise. And so we started doing some tests, and we realized that up to about the firmness of Duke, bruising and firmness are really strongly correlated. And you get firmer than Duke, and that correlation starts to fall apart a little bit. And so just because I think there's a lot of different traits contributing to firmness, and some of them influence bruising more than others. And so we've started putting our selections basically through a screen where we are dropping them and then letting them sit. You don't see the bruises right away, so we slice them a few days later. We slice them open, and we're trying to assess the amount of bruising in those berries. And you can see this is a very, very firm selection, and almost every berry here has a big bruise on one side. Another thing that was identified in our survey that we did 2011, 2012 was problems with fruit splitting. And so we initiated some work the following year, starting to look at heritability of splitting. We've got an assay that we do in the lab where we're soaking berries for 16 hours in deionized water, and then looking at the number of split berries afterwards. It actually correlates fairly well with what we see in the field. And we've used that to screen a lot of seedlings and start looking at the heritability of this trait. I think this particular graph was data from either 2015 or 2016. Every year's been a little bit different, but they're all fairly similar, same trend. Heritability on this is around 0.6, so it's a fairly heritable trait, and our goal here is if we can just eliminate the worst splitters in every generation, we should be able to continue moving that trait forward without losing other stuff. Other things, we're collecting data on firmness, bruising, splitting tendency, continuing to do that in our program. We've got a couple of projects to try to map some genes and identify linkages. Again, associated with firmness, bruising, splitting, fruit quality traits that they're really interested in. It'd be nice to have some markers for those, so you don't actually have to go through all the work of screening those fruit. That's very labor intensive. We've got another mapping population that we're using to look at how quickly stuff gets blueberry shock virus. And that population also segregates for the amount of flower bud initiation on those shoots. And then we're looking at the possibility of a mapping population for the green fruit drop, vapor drop. We're not sure yet whether we're going to move forward with that, but we're investigating that a little bit more. And then we've got some pathology collaborations with Rishi Berlicoti, pathologist in Agassiz, looking at botrytis and Pseudomonas in some of the germplasm and developing some screening protocols for that. Moving on to raspberries. This last year, we planted about 3,700 seedlings in the field. We made 89 new crosses. A big chunk of those were sort of wild by wild selections that we had made that we're sending the seed to Kentville for our redomestication project. We're pretty excited about that. We evaluated about 4,300 seedlings in the field. I don't remember the exact number on our selections made. I think it was like 86, 87, but I'd have to look that up. We evaluated yield plots. We put in a big new yield trial, and this is kind of surprising to me, but we made 250 eliminations from the program this year on our raspberries. And a big reason to that, you can see this picture here. You can see the amount of winter damage in some of these plots. And so we went through and we basically rated winter damage on the plots. A lot of stuff recovered with secondary buds. A lot of things did not. But we also had a lot of things in here. You can see there's just a nice full canopy behind there. It was an opportunity for the breeding program to get rid of a lot of things that either weren't going to work or maybe were siblings of things that worked better. And then there was also a chunk of those 250 were things that had been slated for elimination for a few years, but we had sort of put them in a pool where we said, okay, these are bad phenotypes. We know they're bad phenotypes, but we're holding on to them in case we get the opportunity to do some molecular work with these. because if you want to map traits, you want to do a genome-wide association studies, you have to have the extremes of those phenotypes in there to be able to do that work. We wrote a big proposal for Genome Canada. It did not get funded. So those ended up on the list of stuff to chuck. And if we have the opportunity to do some of that work down the road, the breeding program is always generating new bad phenotypes. Stuff that we're looking at for grower trial, 1071-27 is an earlier season. It's very firm. It machines quite well, but it's also a light color and it doesn't darken. So it's really something that I think is going to be more interesting for the fresh growers rather than the processed growers. 1079-33 is another one we're bulking to try to get into some trials. For 3 years running in our 2015 planted yield trial, it's always been the second highest yielder every year. The top yielder every year has switched, and every year the top yielder drops way down the list the following year, but 1079-33 has always been right up there near the top. It's got the highest combined 3-year total from that trial. 1084-9 is also yielded well. It's a very large one. I think I've got a picture of it in here. It doesn't pick until it's dead ripe. And so I think if you're going to be looking at it, it's got to be something that you're going to do well on a 2-day rotation. On a three-day rotation through that field, it's a little bit of a stretch. And then 1653-7 is a very new one. It's when we've looked at it in our seedling plots, it's got between 25 and 30 berries per lateral. So we know it's got yield potential there. It looks really good when we run the machine harvester over the row. And one of its parents is root rot tolerant, so we're kind of hopeful about root rot tolerance. And so we're trying to get some plants of that bulked up as well. Other things that we're working on, we're doing some work mapping resistance to Phytophthora root rot, aphids, and RBDV. One of these populations has been in collaboration with Pat. They've looked at root rot tolerance in the field and sent some data up to us, and we're adding that into the maps that we're developing right now. And the idea here really is to speed up the process of reliably identifying some of these traits when we're evaluating selections, and also to identify correlations and linkages with other traits. It's sort of a thing that is underappreciated. A lot of times people talk about, oh, let's map this trait and identify markers for it. It's equally important to understand what's linked to that trait. We have some data suggesting that a lot of the sources of gene BU for RBDV resistance is also linked to a QTL for small fruit size. And so if you got to identify what those linkages are and then identify the segregants in your populations that break those linkages so that you can move forward with those traits. We've also been collecting a lot of data to try to understand genetic structure of earliness and yield components. We have found a negative correlation between earliness and yield in our plots and our germplasm. So the growers are telling us they want earliness, but the growers are also telling us they need yield. And it's not that these things are necessarily at odds, but also trying to identify what yield components are not negatively correlated with earliness that we can focus on so that we can try to move the bar on that. And it's also allowed us to identify some outliers that have some of these traits, some phenotypes that are associated with earliness, that are early, but also have some of these traits that are associated with high yield. And so that's continuing. Having a machine harvester in our seed, running that through our seedling population has been enormously helpful for working on this. We're also collecting a range of data on a whole bunch of germplasm, not just our advanced selections, looking at firmness, fruit size, color, some of the chemistry components, using that to identify potential parents for future work, also looking at trait heritability a little bit, and preparing. So hopefully we'll have a big data set. So if we want to do a genome-wide association study or something like that in the future, we've already got several years of data that we can feed into that, rather than writing a proposal and then saying, oh, by the way, we need to collect 4 years of data on this in the future. So hopefully we'll be set up for that. And then this is some other work we're starting to collect some data for this, but we're also trying to get this underway, and that's developing economic models for raspberry breeding, revisiting our assumptions about what the drivers are of profitability. There's been a lot of focus on yield, but a lot also questions like, if you are able to go a week earlier, how much yield can you afford to lose if you're getting a better price by going earlier? Or if you're saving money pruning, how much yield do you need to compensate that with? And so we're sort of this work is going to be looking at using combination of cost of production analyses that people have done, but also adding in our breeding values for the selections and trait heritability, so that we can identify, okay, yes, yield is important, but it's also probably the lowest heritability trait of all the things that we're interested in. So what can we really move the bar on and maybe have an outsized impact? So moving on to strawberries, because we are running a bit short on time. We didn't make any crosses in 2019. We had a list. We brought plants into the greenhouse to do crosses, and it turns out that only one of the things that we brought in to do crosses with flowered. I have no idea what happened, but we had 6 selections that we had made from the field, dug them, potted them up, brought them into the greenhouse in February, and none of them flowered in the greenhouse. I have no idea why. But that said, we had seedlings from previous years that we were evaluating, and we put in a big, large yield trial to start evaluating some stuff. We had sort of a backlog of day neutral selections that we've had problems getting to runner that we put into that yield trial. So hopefully we'll get a better look at some of our day neutral selections in the future. 10-2-1, we've been bulking up for trial. We've got a few plants out the door. We'll have a bunch more going out for some trials in the spring. And that one we're really excited about. In some initial trials in Quebec a few years ago, it yielded better than Albion. Not quite as good as Seascape for them, but the fruit quality was much better than Seascape. So there's some interest there. And with that, hopefully maybe there's time for a question or two. If not, here's my contact info. I always look forward to getting an email or a phone call from growers with questions or just hearing their thoughts. So please feel free to contact me. Thank you.
Good. We do have time for 1 or 2 questions if there are some out there.
Daryl, I'd be disappointed if you didn't ask a question.
Looking at you might think about this. This is an observation that like that dead plant of your trial, but I kept thinking I had winter injury, but what I started doing, like I would put a copper application after harvest, just right after it when you're doing a cleanup. But the first week of September, between the 1st and the 7th, no later than the 15th, by putting on a copper application, all of a sudden made my winter injury go away.
Yeah. So
and
yeah.
One more too.
Okay.
And in your presentation, like the 16-13 scars really badly, and which doesn't make it for fresh market at all.
Right.
And so a little notation of how the fruit is for scarring, you know, where it tears the stem tears the top out.
Yeah, that's definitely one of the evaluation criteria in our blueberries is the scar, and it's some reason why a lot of things don't make it. I had a picture of that actually in a previous version of this slideshow, and I took it out in the interest of time. As to the raspberries, yes, there's a lot of bud damage that occurs from fungi that you can sort of mitigate with copper, and so they're sort of disease issues that really are masquerading as winter injury. In this case, these are things that we have not seen those disease issues in other years, And this past winter, just the really mild weather up through January, and then February, boom, it got really cold. Some things got nailed hard. And in fact, we could see where we had populations where we had some siblings that had been made from a cross, and some of those showed a lot of winter injury and some of them didn't. And we had used those in other crosses. The ones that had winter injury, all their seedlings, the whole population's rated as having more injury as well. And so whether it's winter injury or disease, it's good opportunity for us to just get rid of that stuff in the program and use the stuff that's better. Thank you.
Thank you. We have a break now until 11, and then we'll be back in here for the future of small fruit pathology research. And if you want to hear more about breeding, we'll be in the Fall Creek room.